Hello everyone, today I'll be going through the Year 12 Methods worksheet 14, and here's the answers first. Yep, cool, let's get started. So the first question, we're looking for the mean of x, in other words, the expected value of x. So we just do x times PR x equals x. So 0 times 0.2 plus 1 times 0.2 plus 2 times 0.5 plus 3 times 0.1 gives us 1.5. Question B, what is the probability that Daniel receives only one phone call on each of the 3 consecutive days? So we know that for one day, the probability is 0.2. So for 3 days, it's 0.2 to the power of 3, which is 0.008. The final question, Daniel received phone calls on both Monday and Tuesday. What is the probability that Daniel received a total of 4 calls over these 2 days? So basically, we're looking for the conditional probability of call equals to 4, given that call for Monday and Tuesday bigger than 1. And that is just equal to the probability of call bigger than 1 intersect call equals to 4 divided by the probability of call bigger than or equal to 1 on Monday and Tuesday. So looking at the intersection probability first, the only 2 possibilities are 1 first day, 3 second day, 3 second day, 1 first day, or 2 for both days. After we work out the probability of each, we add them together, and that's 0.29. And finally, we work out the probability that both days they receive at least 1 call, and that's just 0.8 squared, because the probability of receiving no call is 0.2, so the probability of receiving some call is 0.8, and for 2 days is 0.8 squared. And finally, it's just 0.29 over 0.64, which is 29 on 64. All right, so the first question for this, we need to find an expression for h in terms of d. So we know that the volume is equal to pi r squared h. So 2 on 6 is equal to pi r squared h. Change r to d on 2 because radius is equal to diameter divided by 2. And simplify, then we will just get h is equal to 864 on pi times d squared. The next one, the surface area is 2 pi r squared plus 2 pi r h, but we're excluding the base here. That's why we don't actually need this 2 here. That's why I removed it for the next line here. We replace every single r with d on 2 and replace h with what we found above here. Rearrange, then we'll get what they're asking for, which is pi times d squared on 4 plus 864 on d. The next question, we now want to find the minimum value of d such that we're finding the value of d such that s is minimum and find the minimum value of s. So we solve for s dash of 0 equals to 0 and d is equal to 13 divided by the cube root of pi. And with d equals to 13 divided by cube root, 12 divided by cube root of pi, s is equal to 108 times cube root of pi meters squared. And now we find h when s is minimum. So we just use our equation we find above. H is equal to 864 on pi times d squared. Sub d is equal to 12 divided by cube root of pi. Then we get h is equal to 6 divided by cube root meters. Next question. The expression for v in terms of h, we know that d is equal to 2h. That means 2r is equal to 2h. Therefore, h is equal to r. And therefore v is equal to pi r h, then we change r to h, so we get v is equal to pi h cubed. Find the year such that the top of the statue will be exposed. So my method for doing this question is a bit different to the answers. I guess we'll look at the official answers from VCA first. So how they did it is they did this integral here with the values of t. So from doing that, they got this value here. But in my opinion, I think my method is a bit easier. So what I did is that when the top of the statue is exposed is when the height is equal to 1, right? Because the statue is 1 meter tall. And that happens when volume is equal to pi, because v is equal to pi h cubed, right? So therefore, volume must be pi when h is equal to 1. And initially, v is equal to 216. And so all we have to do, and we know that the volume decreases at 10 meters every year. So all we need to do is that the initial volume minus the final volume, which is 216 divided by pi, and divided by 10, because that's how much it decreases by each year. And we get 21.285. And that tells us, well, as 0 is 2010, this tells us the answer is 2031. So this is the exact same answer as this one right here. So yeah, I think this method is a bit easier to me, but I guess ultimately, which it's up to you guys to use whatever way. All right, now we look at question 3. First of all, we need to find the maximum volume. So I just did f max for c of t for t. This is meant to be t here, not x here. So t is equal to 2 on 3, and we just do c of 2 on 3, and that's 0.61 milligrams per liter. Next, we just need to solve C of 0.5 is equal to C of t. We get these two values because it's asking for when it first reached. So we choose a smaller value. So t is 0.33. The next question, it's just asking for the difference between these two times. So we subtract them, then we get 0.86h. Honestly not sure why this is worth 2 marks, but that's 2 free marks just by subtracting this. And the next one asks for average rate of change. It's basically the gradient formula. So C of 3 minus C of 2 on 3, y2 minus y1 divided by x2 minus x1. So shown here, and we get negative 0.23 milligrams per liter per hour. And it tells us that there's 2 times the instantaneous rate of change is equal to the value we work from above here, right? So we just solve C dash of t, okay, which find the rate of change is equal to that. Then we get t is equal to either 0.9 or 2.12. And finally, if the maximum concentration is equal to that, we need to find the value of A. So there's 2 equations here. First of all, n of 0.5 is equal to 0.74. So that kind of goes to this. The second is n dash of a half is 0 because we know that's the maximum concentration, aka turning point. We just solve these 2 simultaneously on CAS for A, and we get A is equal to 4. Of course, that's after we round it to the nearest integer. Yep, so hopefully that's all clear enough. Here's, I guess, the official answers. Let me know if there's any questions regarding this. Other than that, I will see you all next week.